Thank you very much for coming. So today I will speak a little bit about how not to cook microservices. So it's going to be incomplete guide to build non-working microservices platform. And I came across the pond called Atlantic Ocean from United States, New Jersey, to talk about this. First of all, we need to define a little bit what is the platform for microservices and what do I understand under the platform, because most likely different people mean different things. Usually when I discuss microservices platform with people, I ask them certain questions like, can you deploy some microservice yourself as a developer, not as a DevOps, but as a developer? Let's say you developed some simple HTTP API microservice and you want to deploy that. How you would do this? How much code you need to write? Maybe how many configuration lines you need to produce to just get the service rolling. Other questions are important, like how long it will take your platform to really deploy the service, and what features you get for free from the platform, meaning without doing anything, without doing any additional configuration or anything, you get some maybe observability features, scalability, and others. So usually to understand how good is your platform, I ask these questions, and then I have certain answers in my head. Actually, raise your hand if you are using microservices or multi-services at work deploy. Okay, so yeah, pretty much majority of the auditorium, that's good. Raise your hand if you can develop simple HTTP API microservice and deploy that within 10 minutes. Like if it takes you, not the pipeline run, but the whole thing, like configuration, writing configuration code, YAML files, whatever is needed, infrastructure as a code, whatever is needed to deploy ready HTTP API microservices in less than 10 minutes. Okay, happy person there, like good. Another one, good. You are working most likely with the good microservices platforms. Raise your hand if it takes like maybe up to 1 hour. Okay, that's majority, and maybe up to 1 day. Okay, so these are metrics. What I'm trying to say here, these are objective metrics. You see, even without knowing anything, how your platform is implemented, I can measure and I can understand how good it is already. It doesn't matter for me, like, and for anybody else, for developer, from what components your microservices platform is built. If you cannot deploy something within 10 minutes, then I consider that it has some potential for big improvements. And other things, other metrics I put here on this slide, this is what my personal goal in the platforms that I work on usually. I usually aim for not more than 20 lines of configuration required to deploy a new service. I usually prefer the whole service definition to reside in a single repository. We will talk a little bit more about this today. Of course, no need to talk to anyone to deploy anything, and we will discuss that today too. And basically, you're supposed to get maximum features out of the platform for free. You're not supposed to code something on the service side to get something like observability, for example. It should be provided to you automatically in a good platform. So normally when you ask developers, like, describe me your microservices platform, people would tell you something, oh, we deploy to AWS cloud, we use managed cluster there, we use Kubernetes cluster there. For databases, we use maybe RDS, maybe DynamoDB, and for observability, we use, let's say, built-in CloudWatch, or we host our own Kibana, or something like that. So usually, developers talk about the platform, and they mention things on the right side. Meanwhile, I would argue, and this is my maybe main point of this talk, that the right side is not the platform. It's your hosting solutions, hosting products. It's not your platform. The platform is what you have in the middle. The platform is what developers of those services are interacting with. So usually, in a good platform, developers do not directly interact with the Kubernetes cluster. They interact with your tools that you build for them to deploy to the Kubernetes cluster, and so forth. So those things in the middle, like common build deployment pipelines, permissions model, maybe you provide some standard Docker files, maybe you provide some Helm charts. These are things that form the platform for developers. And you can see, yeah, sometimes it's also common libraries on the services side, of course, included in the platform. We will not discuss that much that today. But yeah, our main concentration will be in the center of this diagram. And I have to say, like, the conversation will be a little bit biased towards my personal experience. So for last 5-6 years, I have built three, maybe 4 platforms. And we usually deploy to AWS cloud. It doesn't matter, actually. Like, the whole conversation is applicable to other clouds as well, and even to self-hosted platforms as well. So yeah, and I will talk about my experience. So what I see from my experience broken in pretty much every company, because in those companies where I worked for, sometimes platform is not ready yet or half ready. And I talk to other people as well. In every company, these platforms usually broken in that way. And yeah, and usually companies do not share what they have in the center. They don't like to talk about this. They do not come to conferences and advertise that because this is not their product. They don't sell it, so they have no incentive actually to share that. And sometimes there are some like really messy things happening in the center. So it's really like no incentive for companies to talk about that. Last general introductory slide: why this is important. Why this is important to have good platform. The left characteristics, which is scalability, resources efficiency, isolation, security, and centralized management, and some more, these are usual characteristics of any microservices platform. If your company is using microservices platform, usually they aim for the left side. They say, we want to use microservices platform because we want to have crazy scalability. We want to have isolation of runtimes and isolation maybe of development. The good platform is providing you the right side of things. It's a good developer experience. It's a self-service, which some might include into the developer experience. It provides development efficiency. So you might run everything efficient in a runtime, but to deploy to that runtime, it takes you 1 day, which is not efficient, right? So the good platform provides you good development efficiency. It provides you flexibility. So simple question: do you think the microservices platforms that you are using, do you think it's possible to uproot them from, let's say, AWS cloud and onboard them to Azure cloud? In most companies, the answer is like, no, this is not going to happen. It will take us 1 year or something. So flexibility, you also can measure that with such a simple questions. Can you replace one cloud to another, or maybe just replace Kubernetes clusters with something else? And of course, like, good abstraction is the way to provide such flexibility. So this is why developing good platform is important. So enough of introduction. Let's go into typical mistakes. This mistake happens pretty rarely these days, but still sometimes I hear this. So I ask, like, how you develop your microservices to the platform, and developers tell me, I just ask DevOps. I don't do anything. Like, I just tell them, this is my code, take it. And then DevOps does some magic, and it's deployed. Why this is bad model? So mainly in this model, of course, there is no developer efficiency. Developers cannot deploy anything fast. They need endlessly to be in interaction with DevOps. Would it be real verbal communications or Jira tickets? Doesn't matter. Like, really, they need to talk to someone to deploy anything. That kills the experimentation in the platform completely. Basically, any experiment is pretty expensive in terms of developers' efforts. And in such models, usually nobody is happy. Developers are not happy because they need constantly wait for DevOps to do something. They need to ask them, and there is always backlog of the tickets and all that mess. DevOps are also not happy, even though they remain gatekeepers in such platform, so to speak, platform. But they are not happy because they are constantly overloaded. They have like long backlog of work items. Another mistake is when there is just no platform at all. Like, nobody is doing the middle. It's just developers who are doing service code. They are also trying to do somehow the middle. I call it Wild West model. In such a Wild West model, usually you can see like different teams are even deploying to different things. Like one team is deploying to Kubernetes cluster, which they created themselves, and another team is creating to the Lambdas, and another team is doing ECS. And they use different tools. It's just up to the team to select what to do. So this is another typical mistake. Basically, no platform, just Wild West. Obviously, this is bad because it's like very hard to maintain this thing whenever you need to, let's say, update images, Docker images across all services to remove the vulnerabilities. So something like that. It's just becoming not possible to update. Even though at the beginning this model might have very good speed, so it's appealing to developers. It gives them agency, like they can do whatever they want basically. So in the beginning they move very fast, and they like this model because of that. But long term, mid term even, that bites them in the back. So this is another typical mistake. For those both two mistakes, it's actually not surprising that organizations are making them still. Sometimes it's not just a mistake, it's a conscious choice. The reason for this is that developing platform is actually expensive. So let's talk quickly, like how much expensive. I can tell you it's a $1 million question. So to develop any meaningful platform, you need at least 2 platform engineers and 2 DevOps. That's at very least a team of 4. And to make it half working, you need half a year, usually reasonably half a year. Most likely you will be able to go into production with that platform in 1 year. So 1 year of 4 pretty good engineers, payroll, health insurance, and everything else in the United States, in total, that's around like $1 million. And by the way, this is very risky. So it's not only about money. You need to hire right people. You need to find people with the skills who have a vision, and this vision should align, and then in 1 year you will get it. So it's expensive and risky. That's why many companies just decide not to invest into it. Another mistake that many companies and teams which are developing platforms are doing, they are not checking the market. They are not checking what's existing on the market. They are thinking, okay, we're tasked to build our own platform. It will be our own closed platform. We don't need to learn what's existing outside because we still cannot use it. And I'm arguing this is not true. You need to really know what platforms are existing for the mass market. Like if you are an individual developer who wants to develop some service and deploy it somewhere, you might use some of these platforms. I just took some platforms that I'm familiar with. I'm sure there are many more. The Flight.io, now very popular. The flight control platform is very interesting because they are actually intermediate layer between you as a developer and the AWS cloud. So this is one of the, I would say, that's the future of the platforms. They will be intermediate layers between you and the serious cloud platforms with a lot of features. So let's take a look at those platforms. Let's not make this mistake. Let's consider what these platforms are doing, how they allow you to define the service. So this is Fly.io. This is pretty much everything that is needed to define Go service on the Fly.io. And you can see how small this code, like it's not even code, it's actually a TOML file. You cannot even call this code, it's just a configuration file. Well, some people argue that TOML is complicated, but anyway, this is how you define the service in Fly.io, Go service. Another example, flight control. JSON file, in this case, again, not the code, just the configuration JSON file. In this case, it's a node service, and you can see on the right side, I provided also the sample for the Postgres database. So in this case, you create the microservice with the RDS Postgres database in AWS cloud. This is it. That's all that is required to create service. Another one is from the platform.sh. They use multiple files, and they call they call things like databases as services for your service. So on the left side, you can see the service definition. In this case, it's a Java 11 microservice. And you can see how you can specify different things like resources, which are required for this service. And as well, yeah, you can say, I want MariaDB database 1, database 2, so even multiple databases you can create for your service. Again, simple, in this case, YAML file, no code, Beautiful platform. Raise your hand if your platforms look like that, the platforms that you work. Okay, yeah, not majority certainly, but yeah, you're probably happy developers. You're working with the good platforms. The point I'm trying to make here, there is no reason to reinvent the wheel. You can steal those principles that I just showed you from mass market existing platforms and implement in your organizations if you are working on the platform. There is no reason to ask developers to code Helm charts themselves. There is no reason to ask developers to code Docker files themselves. Absolutely no reason for that. You saw that. Mass market platforms just do not ask to do that. And by the way, they are making money on this. So they already made some research and development. They already know what's most convenient, most likely. Let's hope they make some money on that. So it absolutely makes sense just to steal from them, steal their design ideas, implement them however it's applicable in your organization. And yeah, and Bill Lumber, do you know this character? It's okay, this is the homework. Watch the Office Space from 90s. It's you will understand this meme. Another mistake that I frequently see, and I made this mistake myself a few times for different reasons. There are two different models how you can define your microservice. So one model is on the left side where you have the whole service definition in a single repo. So you create your repository, you put there some service runtime configuration. In this case, it's a service folder. You can put there your service infrastructure as a code, which is infra folder. And then you have something for building, build deploy pipelines, which is GitLab CI YAML. Obviously, this example is for GitLab CI. And on the right side, there is another approach where you separate your file based on the concern. So something that is related to the runtime, you would put into one repository, which is called manifests, for example. And something that is related to infrastructure as a code, you would put it to another repository, which is called infrastructure, and so forth. That's a typical mistake, very convenient for DevOps, by the way. So DevOps people like this model on the right side because it's very convenient for them to manage this. Yeah, I see people knocking, knocking their heads, yes. So it's very convenient for them, not convenient for developers at all. It's just atrocity to developers. Because to define my service, to deploy it, I need to go to 5 repositories and make open merge requests, and then make sure they all merged and applied. And only then I can proceed to deploy my service. Just doing this routine is already a lot. But then you are losing also some things. You're losing audit. You basically cannot do audit. You cannot understand when changed what. Meanwhile, in a single repo, by commit history, you can clearly see when infrastructure has changed, when code has changed, when configuration has changed. Pretty much everything is trackable through the single repository. Again, this mistake often happens because of DevOps are developing the platform, and they don't treat developers as their clients. They just do what's convenient for them. I'm guilty of doing this mistake myself too. I'm not a DevOps. I'm a platform engineer, so I'm I'm former backend engineer. So I understand the pain of developer more. But sometimes, for different reasons, for security, it's very hard to implement the model on the left side. Nevertheless, we should keep trying. We should keep trying. You saw the mass market platforms. They do not ask you to do 5 repositories. They do not ask you to do 3 repositories. They just tell you drop the file here, everything will work. And the same principles we should follow when we develop platforms inside of the companies. I will walk you through this platform. This is actually a real platform, one of the platforms I worked on. And so I walk you through some mistakes, and here they are not done. Everything is done in a good way here. So I showed you there is a GitLab CI file which is doing compilation and deployment of the service, and there is not much in that file actually. So this file is just referencing another file which is include line here. So we basically reuse pipelines fully. We do not write pipeline for each microservice. If you think about that, there are not so many ways to build node microservices. there are not so many ways to build like Java, let's say Java microservice. Most of the time, the build will be just the same, but if you have good platform, deployment will be certainly the same. So there's no point to have any pipelines customizations here. Sometimes you need some customizations, and they could be provided in the form of flags. Here you can actually see that for this microservice, we skip contract tests. Most likely, this service does not need any contract testing, but we enable performance tests. So you can do some things, some customizations through the flags, but never allow services to define their own pipelines. This is just a nightmare to support. Another thing, which is, again, from the real platform, this is a runtime declaration in the real proprietary platform. You can see here we can specify resources, limits, how much resources we request, what are limits, what are auto-scaling parameters. And if you ever worked with Kubernetes, you probably see that this looks very similar to what goes to the Kubernetes manifest usually. So how it works in this platform, we ask developers to provide these, but then we apply this as overrides to our Helm charts, which are provided by the platform team. So we do not ask developers to write their own Helm chart. We just ask them to provide absolutely required parameters. And actually, if they do not provide anything, some reasonable defaults will kick in, and they do not even need to provide such file. It's just, I'm showing this, for example. Again, do not ask developers to provide Docker files. Do not ask developers to provide Helm charts. All this could be provided and should be provided by the platform. Infrastructure as a code. So let's talk about infrastructure as a code, what mistakes we can make there. First of all, this is, again, from the same platform. This is infrastructure as a code sample. I'm just showing here how in that platform we can create DynamoDB table, in this case SQS, queue, API gateway, and S3 bucket. These are high-level infrastructure as a code constructs. They're so-called constructs. This is actually CDK-TF, so CDK for Terraform, and it's a TypeScript. In this platform, we were using TypeScript for defining this high-level construct. Pretty simple. Again, you can get developers in this platform. They could get like DynamoDB table within like 7-8 lines of code. They don't need to code anything like IAM permissions. They do not need to go deep into the configuration of DynamoDB. And that's pretty much for anything, including databases. It's just a few lines of code needed to get the resource through infrastructure as a code. Let's talk a little bit more about infrastructure as a code. So there are different tools available which are being used. I added Ansible because this is something I have seen myself first in my life as infrastructure as a code tool. Was a long time ago. Lately, CloudFormation, Terraform, and when we talk about Terraform, we mean HCL as a language. AWS CDK, CDK-TF, CDK for Terraform, and there is another one, fancy one, Pulumi. It's also infrastructure as a code tool. There is an obvious trend you can see even here, like those which are later on the list, they are promoting, so to speak, CDK approach. This approach is like they telling you in marketing materials, now you can use any programming language to define your infrastructure as a code. And in their mind, they think that developers are eager to code infrastructure. And then they think to make it fun, we need to give them the language they like. That's not true. Like, I think this is just a snake oil salesman speech. Developers, in reality, are not interested in coding infrastructure at all, like zero interest. They want to get in, make the minimal required work, get out. That's not their main concern. Their main concern is usually business functionality. They're interested to get things deployed as quick as possible. They are not interested to code infrastructure. And this is where a disconnect is between like marketing narrative and reality. And another problem with this approach of coding your infrastructure in real programming languages is that they tell you, like, now you can code your infrastructure in programming language, and what each developer hears, oh, now I can use my favorite language for that. So they say, if you have Node service, we would use the same language for the infrastructure as code. If I use Java service, I will use Java for infrastructure as a code. In reality, that's just not true. In a microservices environments, very often, usually, almost common case, you have multiple technical stacks used for microservices. This is usually dictated even by front end, because front end has this approach, backend for the front end, which is supposed to be on Node.js. So you have Node.js services in your companies 100%, just to host, just to work with the front end. But then for the backend, you prefer something else. You might prefer Scala, you might prefer C#, you might prefer Java. And then, bam, you have at least 2 different technology stacks in your company already running microservices. So when it comes to infrastructure as a code, in what language you're going to do the infrastructure as a code? If you allow your infrastructure as a code to be coded in both of those languages, in Node.js, TypeScript, let's say, and Java, JVM, then you have basically 2 worlds. I'm not sure how to support that. You will not be able to provide abstractions, or if you try to provide abstractions, you will have to do this in both languages, which is double work for the platform. So yeah, this meme, everybody hopes that they will not need to learn new language. Reality is, yes, you will. And usually that fails drastically when you see how Java developers who never wanted to learn TypeScript, they try still to write TypeScript. That looks very funny usually. So yeah, I mentioned a little bit about constructs, like how you can define high-level constructs in infrastructure as a code. So many companies just don't do this. The code on the left side is something you will need to write if you do not provide any high-level constructs from the platform level. You will have to write such code, which is on the left side, actually much more of the code. It just doesn't fit the slide. And you will have to care about many, many things. You will have to care about not just creation of the bucket itself, but you will need to care about like who is owning the objects on the bucket, as here, like the versioning, encryption, and I can bring you more and more and more. Usually, it requires around 700 lines of code just to create the bucket and do the right permissioning on this bucket and enable all the right configuration on the bucket. Option number two, this is high-level abstraction already, so you can take this code from option number 1, generalize that, parameterize that properly, and then you can put it into the new construct. Usually this construct is called a level 2 construct. So on the option 1, we worked with the base level 1 constructs for infrastructure as a code. On option 2, we work with already level 2 construct, which we created ourselves. And it allows you basically to create a bucket pretty simply, just providing a few lines of the code there. In this specific platform, which is sampled here, I checked, we have around 900 lines of code inside of the high-level construct for the creation of the S3 bucket. And of course, you need to provide such high-level abstracts for every kind of resource. So for database, for DynamoDB table, whatever that is, you need to provide high-level resource. And option number 3, this is what I'm dreaming about in all my platforms. In not all of the platforms we were able to achieve this, to come to this state. Basically, I don't want my developers to write any code in programming languages for infrastructure. I don't think this is a sane approach. I don't know why this, I think it's just a marketing pitch by companies which are producing those CDKs. I do believe CDKs are tools for implementing number 3. So your developers should come and in some form of configuration file be able to say, this is my S3 bucket, and there's not much to say, like what else do you need? If you need to provide more options, of course you can do that in YAML, JSON, whatever configuration format you prefer. Again, no code for defining your service, and no code should be required for defining infrastructure for your service. So that's another common mistake. Yeah, and this is a meme to illustrate the situation. So developers in option number 1, which we discussed, they usually lose sleep because it's just impossible to catch up with with all the properties of S3 bucket that you need to set. And platform team could take this burden from developers, could just define this reasonably and update it reasonably whenever it's needed. And so develop good platforms for your developers, and maybe they will have good married life as well. So these are typical mistakes that I see pretty much everywhere. So every company, and I'm sure maybe you noted something for your companies as well, they do these mistakes all the time. Even though they're pretty simple to note, they are very hard to fix, I have to say. The problem with fixing them usually comes from multiplier factor, because you have multiple services. In my current organization, we have 170 services. It's not many. The max I saw in my life was 1,000 services. Usually, if you need to change or fix something in the platform, often it requires to go to each service and do the change there. And sometimes it's automatable, like I can script even the code changes and apply them automatically. Sometimes it's just not possible. I need to manually go through each service and thoroughly do the required modifications. So it's not easy to unroll those mistakes after they are made. Sometimes it takes up to 1 year to clean something. And I have been in this. I have been in these situations. It's emotionally bruising. Just to recap what we discussed today. So you can measure how good is your platform. Ask questions. Ask simple questions. It doesn't matter if it's Kubernetes, if it's ECS. Just ask reasonable questions. How long it take me to deploy? How much code do I need to write? Can I reduce it? That's what characterizes your platform as a good or not so good. For designing of your platform interface, you can learn from the best. You can see what's existing in the market. If those companies are providing those platforms for the mass market, absolutely it should be possible for your organization to provide similar interface. You are actually in a better position. You don't have to implement the same interface completely. You just need the narrow sector of that platform that those companies are providing. Just a reminder, DevOps is not platform. DevOps is not the platform. Some people say DevOps are people, and it's a practice. I heard it's a practice in engineering. The service repository should be just enough. Do not split your service definitions into multiple repositories. That's a very often smell of the bad platform. And build simpler to use and higher abstraction. For developers, it's very natural to build abstractions. Unfortunately, it's not the case for DevOps. They sometimes, that's not their natural skill. They need to learn how to do that. And for that, they need to work all together with developers, with engineers, usually, to learn how to build good abstractions and to avoid this mistake of asking developers for each service to provide endless configurations, endless infrastructure as a code. This is it, actually. And if you want to follow me, one link goes to Twitter, another link goes to LinkedIn. So if you want to connect, feel free. And your questions are welcome. Discussions. Zach, right?
Yeah.
Uh-huh.
Let me get the mic. Hey, Vlad, thanks. A great talk. One of the things that I noticed that on your list of tools, you didn't list the CNCF crossplane on there. Have you had experience with that, and is that something you would recommend?
I haven't used myself. I heard something. No, I haven't used myself, so I cannot speak. No.
Okay.
What's that in the short term? So if you can define.
So crossplane is essentially, I would say, a better form of Terraform. Mm-hmm. It is supported by a company called Upbound, and it's a CNCF project, but the idea is it gives you the full flexibility to define infrastructure as code, to build platforms rather than having just infrastructure as code.
Yeah, so there are some, I have seen similar projects just recently, very similar, released by Microsoft. Mm-hmm. It's called Radius. It was just in Microsoft Ignite. It's a Microsoft, so I'm sure they will find a way to spoil that. But I think they got the idea. They're also following the same idea. Like they ask you not to provide opinionated platform. They say you provide a little bit like configuration, and there is a recipe which is supposed to be implemented by the platform team. Yeah, I haven't seen this approaches yet successfully applied, but yeah, probably my lack of experience yet.
Okay, thank you.
Mm-hmm.
Yeah, I have a question related to, I realize what do you say when you have, let's say, a large project and you could actually invest into a platform because it will be a good investment for a long-term run. However, for me, I usually work with smaller projects, and there is a limit in resources, especially in DevOps. What are your recommendations, except the recommendation of using platforms like Platform SH or Fly.io? Is there a way how to still control the infrastructure, but do not spend a lot of time and efforts for?
Yes, thank you. Very good question. So I don't know the reasons why. I work in the regulated area, healthcare, so we cannot do many things that are available for most of the companies. Just by law, we cannot, unfortunately. But most of the companies actually could and should take those platforms from the shelf. They should just start developing with Fly.io or like that Platform SH. It will take you pretty far. And I was implementing platforms afterwards. Such cases, it's pretty easy to migrate them. So it's not like it's really good path for like small to medium company growth to go from something existing on the market, and then if you feel it's not a good fit for you anymore because you grew, just migrate to the cloud, but build the platform when you're already big enough. That's number one. And another one, flight control. So approaches like flight control, and there is another one, SST.dev. It was not on the slide, but SST.dev. This is like new generation of the platforms. They would like to provide you very good service without you building the platform. So they are being that off-the-shelf available platform that you just apply to your cloud account, which is ideal. Like if I would go to the new company and for whatever reason we decide that should be microservices, I probably would take them and try to work with them as far as possible because it will allow me to avoid that investment into the platform. Even though I'm platform engineer myself, so I'm basically removing my position.
Thank you.
Yeah.
Sorry, I did have one other question. One of the things that when I've built platforms in the past that I've always had struggles with was auto-scaling. Usually not vertically scaling, because you can look at those metrics and those price stay constant, but horizontally scaling. For example, at our current job, or my current job at Novu, one of the things that we have to be able to do is scale with under 30 seconds based on queue sizes. In your experience, how have you handled unique auto-scaling cases with the platform in the past?
So usually we just use whatever is available in Kubernetes lately. Like I'm afraid that became just an industry standard. So like, again, I'm not DevOps. I'm not even setting up those clusters. I'm not responsible for maintaining the clusters themselves. What I'm responsible for is for this interface between services and the clusters. We have some problems with developers being reasonable about auto-scaling settings here. So sometimes developers just don't know, or they don't specify anything reasonable, or they put like max replicas 100, even though they need 5. So this happens. So we have like additional scanners which go through repositories and check those anomaly setups, just to make sure nobody goes crazy. Like, yeah, for immediate scaling, you mean scaling at the spot when you have the traffic spike, right?
Yeah, but I think the question is not right for you then if you're working on the interface.
Yeah. So usually this is enough for us outside of maybe 1 or 2 problems in a year, which happens sometimes because of that. But even then, Kubernetes is pretty good. It's just this setting, like how much CPU percentage you set there. What's your threshold to start scaling? So sometimes we need to tweak it. 80% is not always good. Sometimes we set 50, and then it's scaling pretty quickly, pretty soon. So even if we are hit with the traffic spike, we are still good.
Awesome, thank you.
Thanks. Any more questions? I have one. Just in case you measured, I hope you measured any of the features that you implemented in a platform. Like, can you give an example, like how much, I don't know, maybe it saved some money for your company or something?
Usually that's the problem with my approach. I usually do this from holistic thinking, not from like, let's save money. I do appreciate it, could save money, but it's just my personality properties. I just don't want to wait for my service to be deployed for 1 hour or 1 day when it could be done within 10 minutes. So we didn't measure like directly the impact, but usually the most of impact even not in the infrastructure, not something you can easily count. Like you can count AWS bill, but or like whatever CPU that you spend there, but you cannot count how much time and how much resources you wasted waiting for 1 day of developers negotiating something with DevOps, going through this back and forth. It's just not measurable. Yeah. But it's usually a lot. Usually, like a few times I joined, and the first point even was not even 1 day. Sometimes it takes usually more than 1 day. So, yeah.
Yeah, and then for the whole developers team. See, any more questions? Thanks again, Vladimir. Awesome.
Thank you.